Welcome to the next installment in my video lecture series in economics. This is a very specialized video. It's specifically targeting the courses I teach on Wednesday afternoon. And this particular is the lecture I was going to give on the Wednesday afternoon prior to Thanksgiving. And since I know many students will want to leave campus early on Wednesday to spend time with their families, I thought that I would create a video for them so they would not be penalized for the desire to spend time with their families on Thanksgiving as opposed to listening to me talk about economics. So we're talking about chapter 14 in our textbook, the demand for resources. And there's a few things that are important in this chapter. Understanding and being able to explain resource pricing and why it's important in economics. Also, we're going to be taking a look at the marginal revenue product, in particular how that relates to the demand for a particular resource. So we're going to calculate the marginal revenue product and relate it to the demand for that product. Also, we want to have an understanding of the different factors that influence the demand for a particular resource, whether it's labor or capital. Also, the determinants of resource demand, and also the determinants of resource demand elasticity, i.e. what is going to determine between inelastic or elastic demand, the different determinants between those different states of resource demand, and how firms look at and select optimal combination of inputs. We touched upon this when we talked about cost minimization, but we're going to extend the conversation a little bit further, using what we learned previously with the isoquants and isocosts, but we're going to be taking a look at this in a little bit more detail. And also explain the marginal productivity theory of income distribution. So as we stated previously, one of the things we want to understand is resource pricing and the significance of resource pricing. So in that particular section, resources help to determine how much individuals make, correct? Our labor gives us wages. So it impacts how much money that we have or how much we make by selling our labor in the labor market. Also, individuals will rent out capital, they'll rent out buildings, etc. That cost to a business is income to an individual, and the same thing holds for interest and profit. So realize that the pricing of resources, whether it's capital or labor, is a big determinant in how the flow of income to individuals. Also, we talked about this previously, it's important for cost minimization. As resource prices change, or we have a set of resource prices, wages for capital and the rental rate of capital, we need to know this information because it'll help us determine what is the most efficient or most cost-effective way of producing a level of output. And as they fluctuate, as wages fluctuate or the cost of capital fluctuate, we're going to see into firms switching away from capital and more to labor, or away from labor and using more capital. So it impacts the cost minimization process that we talked about previously. Also, realize that this determines how resources, whether it's labor or capital or any of the inputs that we talked about, those resources get allocated amongst industries and firms, and that allocation mechanism is the price of those particular inputs. So for example, if one industry starts to grow and bids up a certain resource, that'll impact other industries that use that particular resource. And they might react by using a different set of inputs in the face of those higher costs. And also realize that as with anything, there are policy issues associated with resource pricing. So whenever governments are involved in the redistribution of income, whether it's the institution of minimum wage laws, etc., resource pricing is a very important component of public policy initiatives that we see on the national, state, and international level. So we want to take a look at marginal productivity theory and how that marginal productivity is the basis for the demand of a particular resource. So one of the things I want you to be comfortable with is this notion of derived demand. And as it says in your textbook, and I'm lifting this quote directly from your textbook, the demand for a resource is derived from the demand for the products that the resource helps to produce. So to give you an example of this, let's say, for example, I've talked many times in class, I like to eat pizza. So I have a demand for pizza. But when I buy pizza, I'm not just buying the pizza, I'm buying the resources that are being used to produce that pizza. For example, when I buy a pizza, that means I have a demand for pizza. I have a demand for flour because flour is used to make the crust. I have a demand for tomatoes because I get a pizza that's made with tomato sauce. All right, I have a demand for mozzarella cheese because I'm buying a pizza that has mozzarella cheese on it. So my demand for that pizza, there's a derived demand for all the inputs that go into making that pizza. Also, for example, when I buy a pizza, that means I demand pizza ovens. Because in order to make a pizza, the pizza shop has to have a pizza oven. Also, I have a demand for the skills of the pizza maker. So realize that when you're buying a product, you have a demand for that product, but there's a derived demand for all the inputs, whether it's raw materials, labor, or capital. All of those are derived from the fact that you demand that particular product. All right. So we have the marginal revenue product, but what's going to impact our resource demand? Number one, how productive that resource is. So if I own a company, how much I'm going to purchase of a resource is going to depend on how much it can physically produce. All right, if I give a very simplified example, I can say, all right, I have a construction company and I need for holes to be dug. All right, so how productive individuals are in digging those holes is going to impact my demand for that particular product, but also the value. So for example, how productive I am in producing pizza, it depends upon how my productivity, the resource demand, is how productive it's going to be in production of pizza, but also how much can I sell pizzas for. So realize that resource demand has two components, and students oftentimes forget about those two components. It's how productive the resource is in producing that item, and then how much I can sell the item I'm using that resource to produce. So for example, the demand for, let's say, a pizza maker is going to depend upon how well they make pizza, how quickly they can make pizza, but how much I can sell pizzas for. If pizzas are selling for $20 a pie versus $5 a pie, there's a very different demand for the skills of somebody who can make a pizza at those different market values of output. So let's take a look and see how, we can calculate the marginal revenue product. And I want you to be aware of the steps through this particular process. So we've done this before, but I'm going to review it again on how to calculate the marginal product. So we want to do the marginal product of labor. We want to take a look at how much total product, how much our output increases every time I increase my usage of labor. So here you can see, obviously, if I have no units of labor, I'm producing no units of output. Okay? I hire one worker and my production goes from 0 to 8. So the change in output is equal to 8 and the change in labor is equal to 1. So the marginal product of labor when I hire the first worker is equal to 8. And I want to point out to you that the denominator in this calculation is always going to be equal to 0. I set this up so that the change in L is always going to be equal to 1. So just be aware of that. So because we're always dividing by 1 in the denominator here, all we need to really look at is how much total product increases every time I hire an additional worker. So my total product goes from 8 to 15. That means the marginal product of the second worker is 7. total product goes from 15 to 21 when I hire the third worker. That means the marginal product of the third worker is equal to 6. And I continue that process all the way through for the marginal product. Now we want to know what total revenue is. So total revenue is just going to be price times my output. So it's going to be column 2 multiplied by column 4. So 3 times 8 is equal to 24. 3 times 15 is equal to 45. 3 times 21 is equal to 63, and so on. So again, we're just taking column 4 and multiplying by column 2. So for the marginal revenue product, we're going to take the marginal product of labor and multiply by the price. So we're looking at productivity, how much is being produced by each worker, but we're quantifying the dollar value of that by multiplying it by the price of the output it's helping to produce. Here it's always equal to $3. So we take column 3 and column 4 and multiply them together. 3 times 8 is equal to 24. 3 times 7 is equal to 21. 6 times 3 is equal to 18, and so on. Now, if we take a look at this, what do we end up seeing here is we see that the price is constant regardless of the level of output. That is a perfectly competitive marketplace. So be aware of that you might be asked a question, taking a look at this table, that if you see when you're calculating marginal product that the price remains constant, we're talking about a purely or perfectly competitive marketplace. Now, if we take a look at this, we want to compare the wage rate to the marginal revenue product to determine what's going to be our appropriate hiring level. All right, so if I hire one worker, I'm paying them $17 and they're generating $24 in revenue for me. So obviously I want to hire a worker because the value of their output is greater than what I'm paying them to produce it. I hire the second worker, their production is going to be $21 worth of output, and that $21 is greater than the $17 I'm paying them, so I want to hire that worker. So the value of their production is greater than the wage rate I'm paying them. I go to the third worker. The marginal revenue product is 18, again, which is greater than 17. So the value of their production is $18. I'm paying them $17. Therefore, I'm going to see a profit by hiring that third worker. If I go to the fourth worker, what do we see that happens? We see that the value of the production of that fourth worker is $15, but I'm going to pay them $17. So it doesn't make any sense to pay somebody to produce $15 worth of output and pay them $17 to produce $15 worth of output. So we would hire 3 workers in this instance because after the third worker, the cost of that resource is going to be greater than the value of their production. So we would only want to hire 3 workers in this case. So realize that if the marginal revenue product is greater than the marginal resource cost, you keep using more of that resource. Again, it's that notion that we're looking at marginal benefit versus marginal cost. And if the marginal revenue product is less than the marginal resource cost, we use less of that resource. So let's take a look and map out and graph out what the marginal revenue product curve looks like. So I'm just taking the data for marginal revenue product and the units of labor and mapping that out. And as you can see here, that when I do that, when I map out columns 6 and 1, I end up with a downward sloping marginal revenue product curve, which is very similar to or identical to the demand curve for this particular product. So realize that the marginal revenue product is a proxy, or in some instances, depending on the market, is a perfect match for what the demand for that particular resource is. Now we can slightly complicate this by having an adjustable product price here. So you can see here the product price is decreasing as output is increasing, and go through the same analysis here. So again, the marginal product is just the change in total production. It's the change in total product divided by the change in the units of resource that we're using, labor. And again, the denominator here is equal to 1. So we're always going to be dividing by 1. So all we really need to do is take a look at what's going to be the change in total product. So when I hire my first worker, total product goes from 0 to 20. So the marginal product of the first worker is equal to 20. When I hire my second worker, total product goes from 20 to 38. So the second worker is providing 18 units of output. So the marginal product of labor is equal to 18. When I hire the third worker and use them in the production process, my total product goes from 38 to 54. So the change in total product is equal to 16. And I continue that calculation down the column. Total revenue, now we'll take a look at total revenue. Total revenue, as always, is price times quantity. So column 4 multiplied by column 2. So we have 20 times 3 is equal to 60. 38 times $2.80 is equal to 106. 54 multiplied by $2.60 is equal to 140, and so on. And lastly, we can calculate the marginal revenue product, which is going to be columns 3 and 4 multiplied together. We take the marginal product of the workers multiplied by the product price, and that gives me what the value of their production is equal to. So we have 20 times 3, $18 times $2.80, and so on. All right, so remember, when we're doing total revenue, it's 2 times column 2 times column 4, so we have 20 times 3. For total revenue, it's 38 times 2.8. It's 54 multiplied by 2.6, etc. And for marginal revenue, it's column 3 and column 4. This market structure is an imperfectly competitive marketplace because as output is increasing, the price is falling. So this could be a monopoly, monopolistic competition, or an oligopoly marketplace. So if wages were equal to 17, how much would you hire these workers? Well, we would continue hiring as long as the marginal revenue product is greater than the marginal resource cost. So our marginal resource cost is equal to 17. So the first worker, we're paying $17 and they're producing $60 worth of output. So we would definitely hire one worker. When we have 2 workers, the second worker, the value of their production is equal to $50.40, which is greater than 17, so I would hire the second worker. For the third worker, the marginal revenue product is equal to $41.60, which is greater than 17. So we would keep going. We would hire the fourth worker, the fifth worker. We would not hire the sixth worker because we would be paying that worker $17 to produce $16 worth of output, which means we would lower our profits by $1. We would generate $16 in revenue, but our cost would be equal to $17. So we'd actually be lowering our profitability by doing that. So we would hire up to the fifth worker, and that's where we would stop our hiring. Determinants of resource demand. All right. So if we take a look at this, if you think about it, if there's a change in the product that's being produced and the demand for a particular product, that's going to change the demand for the inputs or the resources used to produce that. So for example, if I keep to the pizza example that I talked about, if there was a change, if there was an increase in the demand for pizza for some reason, and the average price of a pizza pie went from $12 to $20, so as the demand increases, this drives the price up of pizza. That's going to drive up the prices of the resources that are being produced, that are used to produce pizza. All right? So realize that as the demand for what you're producing changes, that's changing the demand for that particular resource. All right? So make sure you understand that whatever you're producing, whatever the resource that you are is producing is sensitive to the demand of what you're actually producing. Productivity is going to change that. So if individuals are more productive, there's going to be greater demand, because if they're producing more per unit, that means the marginal revenue product is going to increase. So if we go back to the changing product demand, remember that the marginal revenue product is determined by productivity and the price of the output. If there's an increase in demand, price goes up, that means the marginal revenue product goes up. If we're talking about productivity, that means, remember, those were the two components of marginal revenue product, the productivity plus the price. So if individuals are producing more, each individual is producing more, that means the value of their production is increasing, even if the price stays the same, because they're producing more. And also the changing prices of other resources. So for example, if other resources are being used in the production process, that is an important thing, because some resources you can substitute away from. All right. So for example, if there was a robot that could make pizza, all right, if the price of and that capital became cheap enough that it supplanted the individuals who were the pizza makers, that would change the demand for that particular resource, for that particular skill. So the elasticity of resource demand, how responsive, for example, how much people want to use labor, how sensitive that is to changes in the wage rate. So there's a couple of factors that are important, and that's what we're talking about. The elasticity of the resource demand is the percent change in the resource quantity demanded divided by the percent change in the resource price. So make sure you're comfortable with that. We went over elasticity in the first 5 weeks, but realize that we're resurrecting this particular measure. The level of substitutability. Is it very easy to substitute one resource for another? For example, can we easily substitute capital for labor? If that's the case, then the changing of the wage rate will be very responsive. All right, the quantity demanded will be very responsive to changes in the wage rate, because if we can shift over to capital very easily, any increases in the wage rate will cause a dramatic decrease in the quantity demanded of labor, because we can substitute away from labor and into capital. All right. Also realize that the elasticity of the resource demand, i.e. if we're talking about labor, is related to, and there's a positive relationship between the elasticity of the product demand and that how it relates to the elasticity of the resource demand. So for example, if let's say the demand for pizza was inelastic, that people, if prices went up, still bought the same amount, that means that the demand for laborers would also be inelastic. All right. So realize that there's a positive relationship, that if the product demand is inelastic, then the resource demand is inelastic. If the product demand is elastic, then the resource demand is elastic. And also realize that the ratio of resource cost to total cost is very important. For example, if we stayed with the pizza example, let's say that 90% of the cost of producing pizza was labor costs. Then the elasticity of the resource demand would be very sensitive to changes in the wages paid to people who made pizza. The reason for this is that an increase in the wage rate would dramatically increase costs when wages are 90% of total costs. If the wage costs were insignificant, let's say wage costs were 1% of the cost of making a pizza, then it wouldn't be very responsive to changes in the price of pizza makers, the wage rate paid to pizza makers, because it wouldn't really drive the price of pizzas up that much, because wage costs are such an insignificant component relative to the total cost of producing a pizza. Now, we talked about optimal combinations before, and what we stressed was the least cost method, where the marginal product of labor divided by the price of labor should equal the marginal product of capital divided by the price of capital. The profit maximizing rule extends this a little further in that now we're going to be multiplying the marginal product of labor and the marginal product of capital by the price of the output. So we're going to be looking at the marginal revenue product of labor and dividing that by the price. So all we've done here is taken the marginal product of labor and multiplied by the price of the output to give us the marginal revenue product of labor. And we've done the same thing here. We've got the marginal product of capital, and then we're multiplying it by the price of the output that capital is producing to give us the marginal revenue product of capital divided by the price of capital. And this is extended even further because these ratios here, the marginal revenue product of labor divided by the price of labor, should equal the marginal revenue product of capital divided by the price of capital, and that should equal 1. If that is the case, then you're achieving profit maximization using the marginal revenue product. And let's go through a couple of examples here, or just one example. So here's a firm, it's producing an output and it's selling it for $3. It pays labor $15 and it pays capital $24. The cost of capital is equal to $24. So we're going to take a look at what's going to be the optimal level of workers and capital in order for this firm to maximize profit. So once again, we're going to be calculating the marginal product of labor and the marginal product of capital. Again, I want to point out to you that I've set this up so that the denominator, that the change in labor is always equal to 1. So we're always dividing by 1 here. So all we need to take a look at is the increase in total product. So when I go from 0 workers to 1 worker, my total product goes from 0 to 8. The marginal product of labor is equal to 8 for the first worker. Then I hire the second worker, and my total product goes from 8 to 15. So the marginal product of labor is equal to 7. I go from 2 to 3, and the total product goes from 15 to 21. The marginal product is equal to 6. And I continue that calculation all the way through. Total revenue is just going to be the price, $3, multiplied by total product. So it's going to be 3 multiplied by this column here. 3 times 0 is equal to 0. 3 times 8 is equal to 24. 3 times 15 is equal to 45. 3 times 21 is equal to 63, and so on. So I continue that calculation down that column. And finally, I get to the marginal revenue product of labor. So I just multiply the price of the output. The output price is equal to 3, and multiply it by column 3. So 8 times 3 is equal to 24. 7 times 3 is equal to 21. 6 times 3 is equal to 18. And I continue that through the rest of the column. And I do the same exact process for capital. All right, now I'm calculating the marginal product of capital. Again, the change in capital is always equal to 1, so the denominator is always going to be equal to 1. So all I really need to do is take a look at the change in total product as I hire that one additional unit of capital. So when I have no capital, my total output's equal to 0. When I have 1 unit of capital, total product goes to 20, so the marginal product, I'm sorry, I got a little ahead of myself. This is going to be the optimal amount of labor to be used. Why? Because this is where the marginal revenue product of labor divided by the price of labor 15 is equal to 1. So I take this 15, divide by the price 15, and I get 1. So we can go back over here to capital, and the increase in total product is equal to 20. Go from 20 to 37, 17, 37 to 15 is equal to 14, 51 to 62, etc., etc., etc. So we do that calculation all the way through. We follow the same process here for total revenue. All right, so we take the price multiplied by the total product. So 0 times 3 is equal to 3. 20 multiplied by 3 is equal to 60. 37 multiplied by 3 is 111. 51 multiplied by 3 is 153, and so on. And lastly, I can calculate the marginal revenue product of capital, which is the price, the output price 3 multiplied by the marginal product. So 3 times 20 is equal to 60. 3 times 17 is equal to 51. 14 multiplied by 3 is 42, and so on. And remember, I keep hiring capital until I get to the point where the price is equal to the marginal revenue product of capital. So I would hire 5 units of capital. So I selected 4 units of labor because that is where the marginal revenue product of labor divided by the price of labor, the wage rate, is equal to 1. And I select the level of capital where the marginal revenue product of capital divided by the price of capital is equal to 1. So that's going to be 4 workers and 5 units of capital.